Okay. Um, Dear students, today we shall discuss about the requirements of a good distribution system. Then we shall discuss about uh, the calculations that are involved in AC distribution, how to calculate the AC distribution, uh, numericals. Then what are the methods of solving AC distribution uh, problems. Okay, there are two methods of solving AC distribution problems. Okay, there are two methods. One is power factors referred to receiving end voltage. Another one is power factors referred to respective load voltages. Okay, so we shall discuss uh, one by one. Let us first discuss about the requirements of a good distribution system. There are three requirements basically. One is a proper voltage, another one is a availability of power on demand, and third one is reliability. So a considerable amount of effort is necessary to maintain an electric power supply within the required uh, within the required limits, you can say, requirements of various types of consumers. We have different types of consumers: domestic consumers, industrial consumers, and your you can say corporates, like all these different types of consumers. We have to take the demand or requirement of each of these different types of consumers, and we have to maintain the electric power supply continuously. Some of the requirements of a good distribution systems are proper voltage, then availability of power on demand, then reliability. Okay, then what is this proper voltage? One of the important requirement of a distribution system is that voltage variation, that is fluctuations at the consumer's terminals, should be as low as possible. There, in fact, there should not be any voltage fluctuations at all. But the voltage fluctuations you cannot eliminate completely, but you can try to minimize as low as possible. The changes in voltage is generally due to variations in the load on the system. Um, like you can have whenever the load is put on immediately onto the system, then there may be a drop in the voltage, or when you throw off the load from the system, then there will be high voltage. Okay, so this is the fluctuations, this is the variations in the load on the system. So low voltage, what is the effect of low voltage now? The low voltage causes loss of revenue, inefficient lighting, and possible burning out of motors. These are the effects of low voltage. On the other hand, high voltage causes, what are the effects of high voltage? You might have experienced this also. Whenever there is a lightning, then some of you might have seen your TV might have burned out, your fan, fridge, these are, and motors also. So these are the effects of high voltages. High voltage causes lamps to burn, and it will burn out permanently and may cause failure of other appliances. So therefore, a good distribution system should ensure that voltage variations at the consumer terminals are within permissible limits. Within the permissible limits, according to Electricity Rules Act, Electricity Act, this permissible limit is plus or minus 5% of the rated value. Plus or minus 5% of the rated value is what? If the rated value is 230 volts, then it should not exceed 242 volts, or it should not go below 213 volts. So if it varies, the voltage variation is between 213 volts to 242 volts, then it is acceptable. Then it is acceptable according to the Electricity Acts. Okay, so we have to ensure that a proper voltage has to be supplied to the consumers. This is the requirement of one of the requirement of the good distribution system. So you have to maintain, you have to minimize the voltage fluctuations at the consumer's end. Okay, and second requirement is availability of power on demand. Power must be available to the consumers in any amount that they may require from time to time. Okay, power must be available to the consumers whenever they require, whatever the amount they require. It must be available to them. For example, motors may be started or shut down. Lights may be turned on or off. And this can happen without prior notice to the supplying company. Therefore, you should remember that as the electrical energy cannot be stored, therefore the distribution system must be capable of supplying load demands of the consumers. So this requires the operating staff must continuously study the load patterns to predict in advance those major load changes that follow the known schedules. So the electricity supply company must know what is a load schedule in advance. Okay, so the consumers must be given the power what they require. Okay, and third one is reliability. Reliability in the sense you must continuously supply electricity to the consumers. There should not be any breakage, any blackouts. Okay, modern industry is almost dependent on electrical power for its operation. Homes and office buildings are lighted, heated, cooled and ventilated by electric power. This calls for reliable service. Unfortunately, electric power, like everything else that is man-made, can never be absolutely reliable. Okay, reliability means you have to supply the electricity continuously, but unfortunately you cannot ensure 100% reliable operation. You might have experienced this also. However, the reliability can be improved by considerable extent by interconnected system, by reliable automatic control system, by providing additional reserve facilities. You can improve the reliability, but it's unfortunately it is not 100% reliable. Okay, but you have to make an effort to see to that we can achieve 100% reliability. Okay, so these are the requirements of a good distribution system. Okay, next we'll discuss about what are the steps that are involved in AC distribution. Okay, first one is the difference between AC distribution and DC distribution is in DC, okay, we have not studied the DC distribution, but this DC distribution forms a base. Okay, in DC distribution there is no question of impedance like capacitance effect, inductance effects, but in case of AC distribution you have, unfortunately, you have to take the effects of inductive reactance and capacitive reactance. In DC distribution there is no question of a power factor, but in case of AC distribution you have to consider the effect of power factor. Okay, let us see one by one what are the steps involved. The voltage drops are due to combined effect of resistance, inductance and capacitance. Okay, this is the first thing you should keep it in mind. Second one, additions, subtractions of currents or voltages are done vectorially. You cannot do it mathematically. Remember, okay, you cannot add directly, subtract directly. It is vectorially. You have to make additions and subtraction through vectorially only. Third point is the power factor has to be taken into account. You have to consider the power factor of the load. Loads connected to the distributor are generally at different power factors. You cannot ensure that all the loads are inductive only. All the loads that are connected to the distributor are all inductive or all capacitive or all resistive. You cannot. They may be a combination of all these three. So the power factor differ. So therefore, the loads connected to the distributor are generally at different power factor. There are two ways of referring power factors. One is it may be referred to supply or receiving end voltage, which is taken as reference factor. That is power factor referred to receiving end voltage, or it may be referred to the voltage at the load point itself, isn't it? Okay. Let us see this. Okay. Methods of solving AC distribution problems. Let us consider the first one. Power factors refer to receiving voltage. Well, I think I am not be able to complete this within the stipulated time. Okay. I can only record up to 15 minutes, not more than that. Already I have completed almost 12 minutes. So I will take up this in completely in the next video lecture. Okay. So you should remember these 3 points here. One is the voltage drops are due to the combined effect of resistance, inductance and capacitance. Additions and subtractions of current or voltage are done vectorially. Third one is the power factor has to be taken into account. There are two methods how you can take the power factor into account. One is with respect to the receiving end voltage, which is taken as a reference vector, and the other one is maybe it is referred to the voltage at that load point itself. I mean to say that, say for example, I can take this receiving end voltage. Okay, this is a distributor. Okay, this is a distributor, and these are the loads, two loads. So one method is you take this as a reference vector. VB is a receiving end voltage. Okay, there are three voltages: VA, VB, and VC. Okay, VB is a receiving end voltage. So you can refer VB. You can take VB as a reference factor. Then you can calculate the these are the power factor that are referred to this. Other method is you can take the power factor with respect to this load voltages only. VC is a load voltage and VB is also load voltage, considering the points at these points. Okay, so these are the two methods which are used to solve the AC distribution problems. Okay, we will discuss in detail in the next lecture. Okay, thank you.